Hi, welcome to Foundations of Visualization. Today will be our first lecture on the basics of what we call visual mapping, the process of translating data into a visual space. We'll cover a series of tips and tricks for choosing effective visual representation. We'll also cover a wide range of the libraries of visual channels that you might use when you're creating your visualization. Looking forward to discussing all of this with you as we continue in this week's lecture. Today is the first of 3 videos on the basics of mapping data to visual channels in visualization. And I want to start by just discussing this concept of what is a mapping. A mapping in the context of visualization takes on much the same meaning as we see in mathematics. Mappings are essentially functions that translate values from one space to another. And in the case of visualization, we're thinking about the translation from data space to a visual space. How do we get from the raw data in our database or a table or a CSV to some sort of meaningful visual representation that underlies our basic visualization design? Part of understanding this mapping process is understanding how do we think about data abstractly. And while many of the courses in this program will spend a lot of time thinking about the ways that we schematize and abstract data, in practice for this course, the way I want you to think about data space is that data sets are formed of a series of dimensions, or you might also hear me refer to these as attributes. And each of these dimensions have a type. We can think about these types at a very high level to understand and guide the kinds of mappings that we might construct from data dimensions to meaningful visual elements in our visualization. The 3 core types of data space types that we think about in the context of visualization are categorical data, ordinal data, and continuous data. And while a different data set often has combinations of these 3 data types, typically speaking, our data dimensions or our data attributes can normally be described using one of these 3 labels. So when we're thinking about categorical data, this is where the meaningful distinction between data points is simply that they're different categories. So you can think of things like cats versus dogs versus birds. There's no value judgment between a cat and a dog or a dog and a bird, other than the fact that they are distinct categories or classes of data. We can also think about ordinal data. So this is thinking about the relative ordering of different kinds of data values. In these cases, the differences between 2 data elements are simply directional. So I have something like small, medium, large. I know that small is smaller than medium and large is larger than medium, but I don't necessarily have a good absolute value difference of just how much smaller small is than medium. And finally, we have this idea of a continuous data attribute. The basic idea here is that the magnitude between data values truly matters. So if I have 1, 2, and 3, I know the difference between 1 and 3 is twice as large as the difference between 1 and 2. When we think about the other side of this mapping, the visual space, we're going to think about the ways that we represent marks. And as a reminder, a mark is a visual element used to represent a data point. There is a massive library of visual channels that we can use to represent data. These channels range anywhere from position along an axis, so how high is a data point on a y-axis, to things like color, is the data blue, is it green, or even less conventional methods for representing data like motion, how fast is it moving, what direction is it moving, or textures. And the truth behind these visual channels is that the most effective ways of representing a particular data dimension or data attribute are typically a function of its type. When we're thinking about ordinal or continuous data, where the magnitude of the differences may matter, Then we might want to privilege channels like position, size, value and lightness, orientation, these channels that intuitively suggest a continuous range of values. Whereas when we're thinking about categorical data, things like, am I dealing with cats and dogs, apples and oranges, then I might choose encodings that are leveraging intuitive categorizations, things like, am I seeing blues or greens? Am I seeing circles and squares? Here, that visual representation doesn't necessarily inherently imply any value difference intuitively, but we can intuitively and quickly see that there is a difference between values from our visual mapping. So as a recap of what we've talked about so far, mapping really is this process of applying these visual channels, or we'll also call them visual encodings, to data. And there are two questions that can arise in the process of creating a visual mapping. And that is, what is the most effective encoding to use? And how do we compute the visual representation from the data value? We'll talk about this, how do we compute our visual representation, as part of our next video. But I want to first start with this idea of what visual encodings are reasonable to use. And we can use the way that we perceive and intuit different visual channels, so things like position and color, to choose the kinds of patterns that we want to stand out. And this relates to a series of principles you'll see in visualization design called expressiveness and effectiveness. Put succinctly, when we talk about expressiveness, our visual encoding should express all of, but only the information that is appropriate for our dataset attributes. For example, when I think about the color of a mark, is it blue, is it orange, is it green? There's no necessarily intuitive value mapping. I can't necessarily say how much bigger orange would be than blue or how much bigger green would be than orange. Whereas if I map that same data to lightness, as I see on the right here, then I might be able to say, as values get lighter, they intuitively will get smaller. So I can say roughly how much darker is 1 than 2 or 2 than 3. When we think about the idea of expressiveness, what this means is that if we have categorical data, we're going to want to map that to visual channels that likewise simply show differences but don't suggest a magnitude between those differences. Likewise, if we're thinking about continuous data, we will want to choose visual representations that show the continuity and help us internalize the magnitude of our data differences. So if I have categorical data, I might use the encoding on the left, where I have my blue, my orange, and my green. Whereas if I have continuous data, I would probably want to use the encoding on the right, where I am moving from dark values to light values. The idea of expressiveness is complemented by the idea of effectiveness, that the importance of our attribute should match the salience of our visual channel. In other words, the differences that we see should be intuitive to the way the data changes. For example, if I have continuous data and my 3 values are 1, 2, and 3, if my marks get smaller as those data values change, as the data values grow, that wouldn't be very intuitive. People expect that a larger mark implies a larger value. And so what this means is that I can accidentally mislead people if I misuse the principle of effectiveness. By making larger values smaller, someone who doesn't pay close attention to the legends may take away the exact opposite impression that they should from their data. They may think values are going down when in fact they're going up, and vice versa. To practice with this idea of expressiveness and effectiveness, I'd like you to go ahead and grab either a piece of paper or your favorite graphic editing tool and sketch out some designs for some very basic data sets. What I'd like you to practice with is use at least 2 different encodings or visual channels to represent each of the following 3 data sets. So our first data set is small, medium, large. Our second data set is 0.5, 1, and 5. And our third data set is cats, dogs, and parrots. And as a hint for this activity, you want to think about what is the data type you are working with in each of these three data sets, to think about how might you choose effective visual channels for representing these data sets in the context of expressiveness and effectiveness. If you'd like, you are welcome to share your results in the discussion for this lecture, and also to browse ideas that others have posted. Hopefully this will give you a little bit of information and a little bit of a sense of the pure variety of ways that we can choose to represent even very simple data. With that, I'd like to wish you the best of luck in your activity, and I look forward to seeing you in our next video lecture, where we will cover some common tips for using mapping effectively across different visual channels.